All right, we were on concavity. So a graph is concave up on the interval A to B. Notice it's an open interval. If the graph lies above the tangent lines at each point in the interval A to B, a graph is concave down on the interval A to B if the graph lies below the tangent line at each point in the interval A to B, so concave up is when y double prime is greater than 0 at every point in A to B.
So I'm at that spot where you have that arrow. I haven't started writing that yet, but I only have 2 lines left. So should I go to the back of the page?
This is one line and there's one more.
Okay.
And then there's going to be like 4 graphs that you'll want to probably just start on the back at that point, obviously.
Thank you.
So concave down, y double prime is less than 0 at every point in A to B.
Like my handwriting changes every day. Like I'm pretty sure I could tell you where we stopped and started my notes just based on my handwriting.
It's very possible. I feel like I do that sometimes too.
Like today it looks a lot neater and smoother. Like you can tell that my R's are R's and not N's or B's.
That's good.
So what kind of stuff are we writing around these graphs?
There's going to be like 2 things being written underneath each one, but it's not longer than my graph is.
Okay.
So far I've drawn on all the tangent lines. I'm going to draw all the curves now. I'm not doing a very good job, but these would be slightly touching, obviously, the tangent line.
Okay, I was like.
Let me see if
wait.
I can redo them a little bit.
I was thinking, wait, aren't they supposed to touch?
Yes, they should be in one little spot. It's like, I didn't do a very good job of that. Whoa. That one was about to intersect multiple times. Okay, good enough. Just for visual effect, that one was really bad. I need to redo that. Virginia's gonna be like, what in the world are they doing?
That one was pretty good.
Okay, they're close enough.
I already forgot how many lines I should leave in between the.
2.
Okay.
Kenny forgot they were having some lunch today at the shipyard, like his group. And I said, were you supposed to bring something? And he said, probably. It's okay though, I just ate the lunch you packed me. And then I said, oh, sorry, or something like that. And then he goes, nah, it's cool. The food had to start with L or H. And I said, what? I was so confused. And then he went lifting and handling, which is like his group. I was like, oh. I was like, did not understand. I thought this was a Christmas lunch. I didn't know why L and H were pertinent to that situation.
Good times.
Yeah. It's okay. I send in cookies like all the time for them, so it's fine.
I love how they all have to be concave and none of them can be convex.
And he said, huh? Oh, yeah, I know. He said no one brought hamburgers or hot dogs.
Oh.
Like the 2 prime H foods. Oh, I think that's hilarious. Anyways.
I wonder, with heap of potatoes.
Heap of potatoes. I should do that at Pi Day. Be like, you have to bring in things that start with the letter of the class that you're in.
Apple cookies.
Probably would be yummy.
I think that works.
But to your concave point, yes, I don't understand why they're all concave, but that's what they always call them. Just call it concavity, and it's where
Like
the
they
concave
don't-
is facing.
They like being on the inside, kind of.
Yeah. I don't know. I guess
You
it's
don't-
like the best part of the Oreo. Gotta be on the inside.
I think the best part of the Oreo is the whole thing.
Well, I mean, yes, I agree.
You know,
but I'm just saying,
when-
everybody
when
would say the middle is the best.
Well, for me, the best is when it's on my tongue.
Okay, valid point.
It's tasty.
With or without milk?
Depends on how much effort I feel like putting into it. And it also depends on where I am. If I'm at school and I'm stealing an Oreo from Abby, I'm not gonna have any milk with it. But if I'm at home and I feel like grabbing a glass of milk, then yeah.
Virginia, when you watch this, please send us a text and let us know how you feel about Oreos and if you prefer the cookie, the middle, or the whole thing, and if it should be dunked or not dunked. Thanks.
Or I guess you could just leave a comment on the video.
For anyone else watching in the future, feel free to leave a comment if you are so curious. This is what happens when it's almost Christmas break and we're doing a ridiculous amount of calculus notes.
Calculus.
Back to points of inflection. The points where the curve changes concavity. From up to down or down to up.
Maybe it would just sound weird to say convexity.
Maybe
Yeah.
just a little bit.
Yeah, I don't really like convexity. It sounds very vexing.
True that. Dear goodness, how much of this do we have left? A lot.
Too much.
Yes. Dear goodness. Okay.
I bumped my finger on a pew at the beginning of fourth period, and it's still bleeding.
That's not good. Do you need a Band-Aid? Because
Uh,
guess what? I have 1 million now.
That's a big number. I think I'll be alright.
Okay. I have a whole pencil box full, so.
Wouldn't want you to be down to 999,999.
Facts.
Regina's really missing out.
She'll hear it later. Hopefully.
Yeah.
We'll know though if she like doesn't listen to it because we won't get a text about Oreos.
Right.
All right, we're gonna have multiple cases. Case 1 is almost 2 pages in length for me, just so you know. Josh is like,
I think I'll start it on.
I mean, it's in steps, so it's not like,
I think I'll start it on this page.
yeah, I think you'll be fine. I mean, you'll get some of it in there.
That just seems like too much to leave empty.
Yeah. Case 1. Functions that are differentiable everywhere.
How many cases did you say they are again?
There's 2, but case 1 has 5 steps. 5? Wait. Yes, 5 steps.
I need more REM sleep. I think it says that it's good for memory, and I keep forgetting things. I haven't gotten much REM sleep, so conclusion: I need more REM sleep.
So the good thing about this case and these steps are this is a lot of times how I actually go through and like do these problems, which can get excessive, and some problems you don't need to do all of it, but depends on what it's asking for. But the very first thing you should do is find y prime and y double prime, because that's going to be used to find other things like our critical points and inflection points and all of that stuff, as well as determining concavity. So after that, step 2 is to find all critical points of y for all x for which y prime equals 0. So notice that's the derivative equal to 0. At each of these x values, the tangent to the curve is horizontal. Well, that's good because this is like the important or critical notes.
Awesome.
All right. 3. Let C be a number for which
He has always wanted to be a number instead of a letter.
y prime is 0. Check the sign
Oh, checking. That's what those
Of-
integrators forget to do, right?
y double prime. Yes, I roll at C.
Imagine they listen to these notes and they realize that I'm talking about them.
Yeah, it's fine. They'll have their own 8th graders to pick on then. If y double prime of C is greater than 0, then C is a local min. If y double prime of C is less than 0, then C is a local max. Note, this is the second derivative test. For extrema. All right. If y double prime of C is equal to 0, then that's a whole other fish to fry. The second derivative test fails.
Like fish.
Specifically fish ice cream, right?
And salmon. Do you like salmon?
I do. Busch Gardens actually makes some bomb salmon. Just saying.
It feels so forced to say the L.
Well, see, it does if I'm just talking about the fish. However, if I'm talking about like the fried patties, I grew up, like my grandmother would make them all the time, and she always called them, she's like, you want to come over for salmon patties? And so like I just thought that's what it was. So when I learned that it was actually salmon, that was like the hardest thing to understand for me. So I say, I want to eat some salmon, but I'll be like, I'm going over to my grandparents' house for salmon patties.
Well, they're called salmon patties, so I guess you're right when you call them salmon patties.
Yeah, but it's really salmon patties, but it just sounds weird to say, so because that's not what I grew up with them being.
Well, the name of the dish is salmon patties. So,
Yeah, but that's not the correct way to say it.
right, but the name of the dish doesn't have to be correct. Also, do you ever write something and then you mix up a few letters and then you have to go erase it, and then you go to rewrite it and you mix them up the same way, and then you just keep doing that?
Yep. You need to be really intentional about it.
Yeah. It's so annoying when that happens. It's really funny when I'm in a quiz mood, though. Because it just keeps happening, so I kind of laugh it off.
The thing that I'm about to write is basically as many lines as this.
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7.
Okay, well then you're probably good.
I don't know how I feel about this whole, though. But it'll be fine.
I think you'll be okay. It's just like one long thing. It's not like little bullet points. It's like one long paragraph.
Ooh, paragraph.
So this is going to be what happens if it's equal to 0, second derivative test fails. This is what we need to do. So, 4. If y prime of c equals 0 and y double prime of c equals 0, and I'm going to tell you, it is very rare that we see this happen, in our textbook at least. Like, I even think in the prep book last year when we were working problems, we saw it happen like one time. So don't stress out about it too much because it's just way more complicated. But just so you know, it is a weird thing that can happen. Check the signs of y prime as x increases through c. If y prime of x is greater than 0 for x less than c, but y prime of x is less than 0 for x greater than c, then where there is a tangent line as x increases through c, there is a local max if the situation is reversed. So that y prime changes from negative to positive as x increases through c. Then c is a local min. Now we're going to have 4 more little baby graphs. With 1 to 2 lines underneath of them, depending on how you space your stuff.
How many steps did you say there were?
5.
So if there was like a little bonus 6th step, would that be like cry?
Probably. But there's also a case 2.
So
We're on case 1.
so can case 2 just be like go?
Case 2 is function whose derivatives may not exist everywhere.
Well, I don't exist everywhere either.
Okay.
Make these graphs smaller than the other ones. Ooh, it's like one of those normal curves. Oh.
You look concerned. Okay.
That second one looks like it's going through something.
He's struggling.
Is it supposed to be built like that?
Yes.
Oh. Is that one of those like?
It's like a parabola with a line.
I was gonna say, is that one of those like piecewise?
Sort of.
functions?
I don't know. I just drew it how it was in the book. Specifically the book I got this from.
Oh. Fascinating. So, on those little loop, the vertical tangent ones, that's what I'm gonna call them, if that makes sense.
Yes.
So, the green line that's like horizontal is going through wherever C is. Okay. I think I made it.
Kenny said one of the things that they brought in for L and H food, he said one of them was a hard cookies.
Oh. Hard cookies.
It's like I didn't know that classified as an H food, that you could just make something extra crispy.
So, a heap of potatoes would work.
Apparently so. Alrighty. Underneath this first one, y prime changes from positive to 0 to negative, so C is a max. This next one, y prime changes from negative to 0 to positive, so C is a min. This one here, the sign of y prime is positive, then 0, then positive. So, no max or min. Over here, the sign of y prime is negative, then 0, then negative. So there's no max or min. I'm okay. No, it's a line from the musical. That's why it popped in my head.
Oh. I wonder if Virginia's gonna make it to that
Strong
rehearsal.
up and cheap. I'm a strong up and cheap. What?
I wonder if Virginia's gonna make it to that rehearsal tomorrow.
Why did I just write F? That's not even the fifth letter of the alphabet. I can't even make that argument.
I think that's what you're. I don't know. I would give this whole set of notes an F because it's too long.
True. I think it's because the first word was fine, so I was gonna just write F, and then I was like, oh. Find all x values where y double prime equals 0. These are possible points of inflection. If C is an x and the sign of y double prime changes, positive to negative or negative to positive, as x increases through C, then C is an x coordinate of the point of inflection if the sign doesn't change. C is not a point of inflection. I'm going to do an example of this so that y'all actually have something with this to associate it to. Find any max, min, or inflection points on the graph of f of x equals x cubed minus 5x squared plus 3x plus 6. So, step 1, we find y prime and y double prime. What is the derivative of this?
First I have to write down what it is.
I didn't turn the tree on today.
And y double prime is 6x minus 10.
Beautiful. Now, step 2 is to find the critical points, which is where y prime equals 0. So, we're going to take 3x squared minus 10x plus 3 and set it equal to 0. What would this factor into? So take out a 3x, I'm left with x minus 3. Take out a negative 1, left with x minus 3.
I can never figure out what the proper way to denote that stuff is when there's like a negative on the second one.
I decide based on what the first parentheses was.
Like, what I mean is, like, I don't want it to look like it's 3x times x minus 3, and then minus 1 times x minus 3.
Technically is.
Well. Yeah. Okay, thank you. My brain understands that now.
Now, I'm the person that doesn't write the plus sign if it's positive, though. Like, if this was a positive, like 2, I would just write 2 there.
Same.
Everybody kind of does it.
Yeah, like, I'm just now realizing that we're factoring out.
Yeah.
You know,
It's okay.
Sometimes I feel really stupid. This is one of those times.
Alright, so step 2 is now complete. We have found where y prime is 0. I'll just get a note. Step 3. Let C be a number for which y prime is 0. Check the sign of y double prime at C. So basically, I'm going to say f prime of 1/3 is equal to 0. So I want to know what f double prime of 1/3 is. So if I plug in 1/3, I'll have 6 times 1/3 minus 10, which is -8. So, and I'm not done, but I'm just going to do work individually. F double prime of 1/3 is less than 0. So, it is a max at 1/3 and f of 1/3. This goes into the original. You'll notice.
It's not any prime.
Nope. So if I wanted to actually give it, the max is at 1/3, and if you plugged it in, just for the sake of time, it would be 175 over 27. Now, that's one of them. I also need to do it at 3. F prime of 3 is 0. F double prime of 3 is 6 times 3 minus 10, which is 8. So f double prime of 3 is greater than 0. So therefore, there is a min at 3, and f of 3, again noting that's the original that it's getting plugged into, and that happens to be 3, -3. Now, step 4 is only the situation when y prime of C is 0 and y double prime of C is 0. We did not have that happen in our case, so step 4 is unnecessary for this problem.
Do you think it would be weird to put mine step 5 if we're doing that over here?
No, it would be fine.
Okay.
I'm going to try to finish step 5 really quick. I may have to do one thing on it tomorrow. Maybe not. I don't know. So step 5 is find all the points where f double prime is equal to 0. They're possible points of inflection. So we say 6x minus 10 equals 0. So x equals 5 over 3. So what I do is I look at a value. If I plugged in a value here like 0. So if I set x is 0 to this equation, I'm going to get that this is equal to negative 10. If x is 2,
What was all that?
this is going into the f double prime. I'm trying to see what happens as I go through that point. So 5 over 3 is a little, well, as I'm like getting closer, I'm trying to see what the sign is changing to. So 5 over 3 is a little less than 2. So I picked a number before and a number after. So this would be, if I plug this in, you would get 2. So this changes from negative to positive. Guys, I'm trying to finish up something. Please be quiet. So this goes from negative to positive. So this changes from negative to positive as x increases through 5/3. So there is an inflection point. And that point of inflection is 5/3 and f of 5/3. You can go. Or this would also be, when you plug that in, 5/3 and 47 over 27. I'll draw the little graph that goes with it tomorrow.